Hello. In these short lessons, I will talk about the theory of relativity. We will start introducing a couple of basic concepts that are very important to explain the special theory of relativity. The first one is the definition of inertial reference frame that now on we will call just like IF, inertial reference frame. The inertial reference frames are all that systems that are moving in a straight line with a constant speed. The speed can be also zero, that means that the system is standing still. The motion is to be defined always in a relative way, because I cannot say that something is moving if I have no other object in a universe. Suppose you have just only a little stone and that's all your universe. How can I say that this is moving if I have no point, no other object to compare with it? So it's important to consider always the motion, the relative motion between objects and between systems. So, for instance, the classical example that Einstein used is just to consider a man standing still on the earth, this is the ground, and a train moving with a constant speed in a straight line. Okay, suppose that this is moving in this direction with velocity v, and suppose that there is a passenger on the train. Okay, so if you look at this picture, you immediately understand that there is a relative motion. You can imagine that the man is standing still on the earth, and let's call this man A, and this is the man B. A is standing still and B is moving with velocity c on board of the train. But if you are B, you can consider yourself standing still on the train, so the velocity v disappears because you are not moving on the train, and you see that the other man A is going away in the other direction with velocity v. This is the relativity of the motion. But this was already well known to Galileo and then to Newton as well, and they knew that all the laws of physics are exactly the same in both reference systems. Let's consider a simple case, an example. Suppose that A, standing still on the ground, is dropping a stone. He observes that the stones hit the ground, falling down in a perfect vertical line. Now, let's go on board on the train, and let's see what happens if now the man B drops the same stone. We see that also in this situation, the stone will fall down vertically hitting the floor of the train, of the coach. And this is due to the fact that this train is another inertial reference frame like the Earth. Because no acceleration is present at the moment, so the fact that the train is going on a straight line with constant speed is just enough to say that the law of physics, the law of nature, are exactly the same. So the fall of the stones, the movement of objects, the oscillation of a pendulum or of a spring are exactly the same here on board and here on the surface of Earth. This is a very important assumption. It is not an assumption, it's just reality, it's just what we see. This was just stated for the first time by Galileo. That is the relativity principle of Galileo. He talked about a big ship sailing on the ocean, and he told that every natural phenomenon happening on board of the ship was exactly the same as the identical phenomenon observed on the Earth. This is exactly the same basic principle that is used by Einstein for the special theory of relativity. So we can say that all the laws of physics, if you prefer, of nature, are the same in all the inertial reference frames. This is just very, very important. The second fundamental assumption used by Einstein is really revolutionary because it is just a new one. This that we have written now was valid also in the Galilean and Newtonian physics. But now, the second one that I'm going to write now is just the big new issue introduced by Einstein. And it is that the speed of light is the same in all the inertial reference frames. If you think about it, you could say, okay, but this is the propagation of light is just another physical phenomenon. So it is implicit in the first assumption that this phenomenon, the propagation of light, must be the same in all the inertial reference frame. Okay, that's partially true, and we want to talk a little bit more about it. first of all, we know, and Einstein knew that in 1905, when Einstein um, introduced the new special theory of relativity, it was already known that the speed of light was constant in all the inertial reference frames because it was just observed experimentally, but there was no total agreement about that, and it was introduced a strange ad hoc concept that is either just to try to explain the apparently strange behavior of light. But why it was so strange? Let's think about it a bit. Suppose that we have our train traveling in this direction with velocity v, and suppose that our man on board throws in the same direction of motion an object with velocity u from the window. Well, it is well known in classical physics that the velocity, this is A, this is B, B sees the stone thrown in this direction with velocity u. So the velocity, let's call B, sees the stone traveling with velocity u because it is still on the train, and so the only one velocity it sees is just u. What about A? A observes the stone traveling in this direction with the sum of the two velocities, because when the stone is in the hand of B, it is traveling with velocity v, that is the velocity of train. And then when it leaves the hand of B with speed u, the total speed will be the sum of the two velocities. This was considering true by Newton. But what is the problem with that formula? Suppose now that Mr. B, instead of throwing a stone with velocity u, turns on a bulb or a torch, okay, emitting light with the proper speed of light c. Okay, so for B himself, the light is going away with the speed of light c, that we know it is 300,000 kilometers per second. But doesn't matter what is it, it is called c, the speed of light, you know. So according to this addition classical formula, Mr. A should see the light going away from him with a speed equal to the velocity of the train v plus the speed of light c. But this is greater than c, so this situation would contradict our second basic assumption that the speed of light must be the same in all the inertial reference frame. So if this formula is true, we have a contradiction with the second fundamental principle. So the Einstein was so brave, so courageous to say, okay, I want to maintain this fundamental postulate, the constants of the speed of light for all the inertial reference frames, and on the other side, I will assume that this formula of addition of velocity is not true anymore. So he decided to substitute this formula with some other stuff compatible with this fundamental assumption. So we will see in the next lecture how he succeeded in this idea, introducing a new fundamental concept, that is the not universality of space and time. This is the true huge revolution introduced by Einstein, because Newton considered the space absolute and the time as well absolute. So the time is passing with a constant pace equal for everybody in the universe. Einstein introduces the new fundamental concept of relative meaning of space and time. But we will see next time. Thank you.